Let's say we want to solve the following system of equations. We're given 6x plus 3y equals 17, and we're given minus 3x minus 4y equals a positive 9. Now, solving a system of equations such as this using elimination is ideal because it gives an exact answer. Whereas graphing, we know, only gives an approximation, and it usually leads to simpler calculations than when using substitution. When using substitution, we're substituting in entire expressions in for one variable, which can be complicated at times. Now, when we have a more complicated system where, like this, where one variable cannot be eliminated by simply addition or subtraction, we can multiply one of the equations by a fixed number called a scalar. A scalar, don't get excited about this term. A scalar is just simply a number. It's a factor where we can multiply something by a scalar, and it just manipulates the equation and gives it in a different form. And we do this so that the coefficients of one of the variables, either x or y, is matched in both equations. So notice here we can't simply add or subtract to cancel one of the variables. If we could only change one of the coefficients of one of the variables to match that of the same variable in the other equation, we could actually add or subtract and do the elimination process. So what if we multiplied this second equation by a factor of 2? So let's take minus 3x minus 4y equals 9, and we multiply this entire equation by 2. 2 is called our scalar, and when we multiply the entire equation by 2, we get the following. We get minus 6x minus 8y, just multiplying each term by 2, equals 9 times 2 is 18. Well, if you look here, we actually have a variable that has the opposite coefficient in both equations. This is the same equation as this. They're both equal. We just changed the form by a factor of 2, called a scalar. So now we can use the elimination method, and we can add these two equations together, and 6x and minus 6x will cancel, leaving one equation with one variable, the variable y, that we can solve and find a value for. All right, so let's go ahead and do this. Let's go ahead and take 6x plus 3y equals 17, and we're going to add this form of our system of equations for this equation, and we're going to be able to isolate one of our variables. So we have minus 6x minus 8y equals 18. We can add these together. 6x and minus 6x will cancel, which gives us minus 8 plus 3 is a minus 5y equals 17 and 18 is 35. Let's go ahead and isolate our variable y by dividing both sides by negative 5. So we have y equals 35 divided by negative 5 is a minus 7. So now we have a value for our variable y. Y equals minus 7. And then we can just proceed like we've always done before, just plug it into either equation to find the value of x. Here we don't have any negatives, so let's go ahead and use equation 1. So we have 6x plus 3y, y is minus 7, equals 17. Let's go ahead and solve for x. So we have 6x, 3 times a minus 7 is a minus 21, equals 17. Let's move everything to the right except for our variable. We're adding 21 to both sides. Those two terms will cancel, giving us 6x on the left-hand side. 17 and 21 gives us 38. Let's go ahead and divide both sides by 6 to isolate x. We should be very good at solving these equations by now, which gives us 38 over 6, which will simplify into 19 over 3 if we factor 2 at the top and the bottom. So now we have our value for x and our value for y. So all we simply have left to do is write our exact solution for our system of equations, which is 19 over 3 and minus 7. And this is the point where these two lines intersect, which is also the solution for our system of equations. So when we don't have coefficients for one variable that match, we can multiply one of the equations by what's called a scalar. In this case, it was just 2, which just changes the form of one of the equations that we can handle more easily. All right, we're going to do some more of these, so let's take a look at the next one. Here we have the system 2x minus 3y, 2x minus 3y equals 6, and also 4x. You have 4x plus y equals 5. Okay, so this is our system, and there's nothing we can actually just add or subtract to make one of the variables go away. So how about we multiply this first equation by a scalar of -2 and see what that does. Because if you see, we have 2x here and 4x here. If we had the coefficients of our x, if they were opposites of one another, if this was a -4x, we can cancel out the x's by adding the two equations. So let's take the first equation and multiply it by a -2. -2 is called our scalar, and this will render -4x. Negative and negative gives us a positive 6y and a -12. So now we have a new form of our first equation that we can we have two coefficients of x that are the opposites, and we can add to get rid of them, solve for y. So let's go ahead and do that. We have 4x plus y equals 5, and we can add the second equation. We have minus 4x plus 6y equals a -12. These two terms will cancel, so we have 1 plus 6 is 7 times y equals 5 minus 12 is a -7. We can solve for y by dividing both sides by 7, so we have y equals a -1. All right, now that we have a value for y, we can go ahead and substitute that into either one equation. Here we have y by itself, so let's go ahead and use equation 2. We have 4x plus y, which is a -1, equals 5. Let's go ahead and add 1 to both sides, which will cancel those two terms. So we have 4x equals 5 plus 1 is 6. If we divide both sides by 4, we just get x on the left-hand side and 3/2 on the right-hand side. 6 divided by 4 can be simplified into 3/2. We have values for both of our equations, or both of our variables, excuse me. So let's go ahead and write our solution. We have the solution 3/2 and -1, which is the point where these two lines intersect. So we're just multiplying one of our equations by a scalar, so we're just simply manipulating one of our equations by doing so it lines up to where we can add or subtract them. All right, let's look at one more. We have the system 9x minus 8y equals 4. We have 2x plus 2y equals -6. Now, 9 and 2, the coefficients of x, they're both, one's odd and one's even, so that actually might not be very simple to deal with, but excuse me, our coefficients of y are both even, so let's go ahead and multiply equation 2, which is 2x plus 2y equals -6. Let's go ahead and multiply it by a scalar of -4. What that would do is multiplying 2y by -4 would, or excuse me, let's multiply it by a +4. If we multiply 2y by a +4, we'd get a positive 8y, which would cancel with a -8y if we combine the two equations. So we're multiplying by a scalar of 4. That'll give us 8x plus 8y equals a -24. So this is our new form for equation 2. Now we can go ahead and combine these two. We can add them using the process of elimination. So we have 9x minus 8y equals 4. And to that, we're going to add this form of the second equation. We have 8x plus 8y equals a -24. And when we add these two terms will cancel, just giving us one equation of 17x minus 20. Solve for one value, or one variable, so we can solve for the value of that variable. These two terms will cancel if we divide both sides by 17. So we have x equals a -20/17. So we have a value for one of our variables, and just like any other method, we can go ahead and plug it into one of the other equations, doesn't matter which one, and we'll get the value for our variable y. So let's go ahead and plug it into the second one. Numbers are smaller and we're not subtracting. So we have 2 times x, which is -20/17. 20 over 17 plus 2y equals minus 6. Y is what we want to solve for, so let's go ahead and isolate it. This 2 times minus 20 is minus 40, divided by 17, plus 2y equals a minus 6. We can go ahead and move everything to the right except for our variable. So we can add 40 over 17 to both sides. These two terms will cancel, giving us 2y on the left-hand side. So we have 40 over 17 minus, let's go ahead and convert 6 into a fraction with a denominator of 17. So a denominator of 17, which if we multiply 17, so that would give us 102. So 2y equals 40 minus 102 is minus 62 over 17. If we divide both sides by 2, or let's go ahead and do it here. So we're rewriting it, minus 62 over 17. We're dividing by 2 here, dividing by 2 here, or 2 over 1. So we get y equals minus 62 over 17. And we don't ask why, but we flip the second and multiply. Get a little room here. We can factor out a 2 to simplify this. This will give us 31. So we have y equals minus 31 over 17. So we have a value for both of our variables. So let's go ahead and state our solution for our system. So our solution is the point minus 20 over 17 and minus 31 over 17. This point where the two lines intersect is in quadrant 3, and if we plug both values of x and y into both equations, they should both equal out. So we're solving systems of linear equation. We're essentially solving them by multiplication. We're multiplying both one equation by a scalar so that we can end up adding or subtracting one equation from the other and getting values for our variables. So we'll do some more of these in the next section. I'll see you in the next video.